Right, so we jumping into the homework. 2x squared plus 3x squared not 3x squared, 3x plus 4x squared plus 5x. So here we could easily identify that the x squareds are the like terms and the x's are like terms. So 2x squared plus 4x squared will give me 6x squared, and 3x plus 5x would give me plus 8x. And like I said, even though your half of your brain focusing on the difference between the x squared and the min and the x and the xy and stuff like that, the other half of mine still have to be paying attention to the signs and following the rule. Right. The next one be right over here. We had x squared plus 8x plus 5x plus 10, and our like terms are only the two x terms. So x squared is going to remain x squared. 8x plus 5x is 15x and plus 10. Any questions so far?
No, sir.
So far, so good. Zane, you got all of these so far, right?
Yes, sir.
All right, nice. Um, Asriel, you here, right?
Yes, sir.
Okay. Any questions? Any deviation? Everything
No,
good so
sir.
far? All right,
All good.
nice. All right. So, Asriel, what do you got for the third one? Let's see.
I got 10x plus 2x squared.
That's right. Or if you have 2x squared plus 10x, which is the same thing. Right. Good afternoon, Maya, and welcome to the class. I think your mic doesn't work, but that's fine. We are just going through the homework, which is the last homework that I gave. If you can, you could just message in the chats. I know if you can't, in the sidebar. Also, to see the entire board, because you might only be seeing, if you're using part of the window, you might only be seeing part of the screen. You want to click on my camera or you want to click on me and pin. It should have a little pin icon, kind of like that pops up when you mouse over it, and that should allow you to see the whole screen. So if you're having any problems seeing the screen or hearing, you could just message me and let me know. Oh, okay, good. So I see your response. Nice. All right, so part D, x squared plus x plus 10 plus x plus 4x squared. All right, so we, of course, our x squared terms, x squared plus 4x squared will give me 5x squared. Oh, what happened there? And x plus x would give me plus 2x plus 10. E, the fifth one, we have 5x squared minus x minus 6x squared plus 8x. Zane, you did this one?
So is it?
You did this one?
Are we on number 5?
Yes, Oh, yeah, on number 5, yeah. What do you
Right.
got for this?
Yeah.
What do
So
you got
I
for this?
get negative
Mm-hmm.
x squared plus 7.
Plus
7x,
7
I mean,
x.
7x.
Yes, that is correct. So 5x squared minus 6x squared. The signs are different, we subtract. So we completely ignoring this because we are combining the like terms, which is the x squared terms. And this negative is part of the 6x squared term. That will give us negative x squared, and then minus x and plus 8x would give us plus 7x. Very good. Next one, 4x squared, oops, minus 3y squared minus x squared plus y squared. And again, this shouldn't be too difficult to differentiate. So our x squared terms, 4x squared minus x squared is 3x squared. And our y squared terms, minus 3y squared plus y squared would give us minus 2y squared. Um, Maya, if you completely lost with all of these x squares and y squares and what is going on and how you get a minus and all that kind of stuff, you had to let me know and I will explain. Um, this might be something we could do also later, but just let me know if you need further explanation and I will either set aside a different session or a different day and I'll explain it to you or not. But I know you're now joining in, and kind of already, it might seem like all right, very good, very good. Well, anyway, I think you repeated, so a lot of this should be kind of familiar. All right, nice. Um, the next one is x squared plus y squared minus x minus y plus squared. Tanya, you did this one?
So, just hold on. Just give me 1 second. Yeah, I didn't. I had done started already.
All right, well, let me see you try this one if you didn't do it.
Yeah, because I was watching. So after that, I put it together like x squared plus x squared minus x plus y squared minus y. So
Right.
right now I reach x squared plus x squared. I'm studying what to put for there. Like I have to put x to the root of 4, or if to put back x squared.
It's not x to the power of 4.
So since I have 2x squared plus x squared, what am I going to do there?
No, right, you have a x squared plus x squared, right?
Yeah,
And you want to know what to do with this?
you're leaving it so?
No. If it was just x plus x, what would you get?
I will get 2x.
Right? So if you have x squared plus x squared,
Oh, it will be 2x squared.
2x squared. Correct.
Okay. So I'll get 2x squared, then have a minus x.
Um, 2x squared, yeah, minus x. What are you doing with the minus x?
Would you will subtract it from the 2x squared?
Well, no, you can't subtract it from the 2x squared because that's not the same term.
So then we will just leave it then.
Just leave it. Correct. That's kind of
So,
what I want to get out of you. Yes, you just leave it. And what
alright.
else?
So 2x squared minus x. So now I have plus y squared minus y. Will end up with just a plus y
Plus y squared
minus
minus
y.
y. All right, good. This is interesting. This is interesting. Let me actually put this aside. And this is common, but I want you to be very careful about this. You're looking at plus y squared minus y. But here's what you are thinking. You are thinking if it's the same as plus 2y minus y.
Yeah.
Y, this would give you y because this is 2y minus y. This, you can't subtract y squared minus
From
y.
one.
This is not the same term. 2y means you are multiplying y by 2. Y squared means you're multiplying y by itself, but you don't know what y is. So you can't subtract y squared from, you can't subtract y from y squared to get any kind of value because you don't know what y is. Y is a variable. Y squared is also an unknown variable. These cannot be combined. So it would actually just be plus y squared minus y.
Okay.
And that would be it.
Yeah.
But again, the point is, treat don't treat the y squared. And it's the same thing when you were looking at the x squared plus x squared and thinking, do you do something with this or do you do something with this? This is just two of the same thing because we add in. If you add the same thing by itself, you get two of it. If you multiply x squared by x squared, then you would get x to the power of 4. So, and we will come to that because, of course, we're leading up to more higher exponents and that kind of stuff. And I even the example I gave the other day when had x cubed. And it does seem like, what are you doing with all of these x's and x squared and x cubed? But you cannot combine x squared and x cubed. They are not the same term. You cannot combine y squared and y. They are not the same term. So this is the answer. Got it?
Yeah.
Very good. Now let's move on to the next one. Anybody have any questions on that last one?
No, sir.
It may look like you didn't really do much simplifying, but that's the point. If it can't be simplified, it can't be simplified. This seems like it's almost the same as this. You only combine one thing, but that's the whole exercise. Leave it as this is as much as you can simplify it. All right, so the next one, and I'm glad I stopped on that one because I kind of wanted to make that point because I figured that would have been one that would have taught some of you guys. So 4x squared minus 7x plus 1 plus x squared plus 4x minus 11. What are we doing with it? Simply, we have a lot of terms, but we can care or like terms. So our x squared terms can be combined, and that would give me 5x squared. X terms minus 7x plus 4x can be combined, and that will give me minus 3x. Signs are different. 7 steps backward and 4 steps forward would give me minus 3. And our 1 plus 1 minus 11 would give me minus 10. Let me, all right. The next is, this one is similar to the one above, x squared minus y squared minus x minus y plus 2x squared minus 2y squared. All right, Kanye, you might feel like I'm picking on you again, but I want you to tackle this one.
All right. So let's give me a second.
Write out the next one in the meanwhile. In fact, could probably write out a bunch of these in the meanwhile. Go ahead.
All right.
Are we waiting on you now?
Yes, sir. Trying to calculate this one here. Right.
Oh, okay.
Yeah. I didn't have it done. I did only do like up to D, and then I didn't finish this.
Oh, okay. You the students that has rushed into class and now doing the homework when you reach in school.
No. That's I feel you gotta help me with this one here.
Right. So we're looking at our like terms, which are our x squared terms. So we have two x squared terms. So we combine. So if we put together the x squared terms, then that's this, and I will use my highlighting in this one, and this, right?
Yeah.
So what are we getting with the x squared terms?
Yeah. You remember the 2x squared?
No, look at it. X squared plus 2x squared. Just
So yeah,
focus on the ones I've
3x
highlighted.
squared.
Huh?
3x squared?
3x squared. Good. Then next, let's look at our y squared terms. So, reason a different color. Right, so just focus on the ones that are highlighted in light blue.
You will end up with negative 3y squared?
That's
No,
right.
negative 3y
Yeah,
squared. Okay, add in.
the
Yeah.
signs are the same. Minus y squared minus 2y squared. So you'll get minus 3y squared. And then what else?
You would just put back the minus x minus y.
Minus x minus y. Perfect. That's the idea. Very good. All right. The next one, Asriel, what you got for this one?
I got 5y squared plus 2y minus 4
Plus 2y, right? A plus y
minus
and
4.
minus 4. Correct. Good. Now we have AB plus CD plus 4AB. And again, the only things that are like terms are the AB terms. So this matches with this. AB and AB, the variables are the same. So this can be added. That would give me 5AB plus CD. There's nothing else to combine with the CD. This one, again, we have XYs and YZs and a bunch of different stuff. The XYs can be paired because XY is like to XY and XZ is like to XZ. So this would give me 2XY and XZ plus 4XZ would give me plus 5XZ. Got it?
Yes, sir.
Right.
So
4AB plus 7AB minus 3AD equal. What are we getting for this one, Zane?
so say over.
What are we getting for this one? 4AB plus 7AB minus 3AD.
Right. So, right? So, 4ab plus 7ab plus, wait, no, take away 3ab,
Yeah.
right? So, we combine the 4ab plus the 7ab, and we'll get 11ab,
Mm-hmm.
and we can't do nothing with the 3ab, so it could just be 11ab subtract, well, or negative
Yeah. You said
3.
there you have it. I using it's trying to use the word minus and plus.
I don't like designer.
I know, but I don't want. I know it's when you say add and subtract, that is an operation and not a sign, and there's a little bit of a difference because it uses the same symbol and the vocabulary and the language kind of could be confusing. But that's fine. If it's more comfortable how you wanna the way you say it, but that's fine. Take away 3AD, 3D, 3AD. As it's supposed to be. Right. And then for the last one, the PQ, not the QRs, the PQs combined with the PQ. So this is 4PQ plus 5PQ, which will give me 9PQ and minus 3QR. And there you have it. That's the working for the homework that we get. All right. So we are jumping into somewhat of a new topic, and it is basically where we have terms. Now, as you guys could see, we have a lot of similarities with terms. For example, I'm sure you guys may or may not have come across the concept of factorization, where you would have a common, like for example, in all of these terms, A is present. So if A is a factor, now when you break down a term, and there's a little, did I save it? I did not, yes, I did. All right. Before I go a little further, I want to give you guys an image that, and I will actually add this to the chat, but I created what I call a diagram. We could call this algebra anatomy. So it's kind of like where you have a diagram of a biological drawing, and you have, you draw and label all the organs and all the stuff of the animal. I want you guys to study this because this all of these terms are vocabulary that you guys need to be familiar with. So I'm going to start all the way from the inside. The smallest component of algebraic anything in algebra is the variable. So the variables are these letters, right? And even though you would use X in your alphabet and Y in your alphabet and Z and all these other letters, in math, when we have a letter, it represents a value that is unknown or can be changed. So it's referred to as a variable. So in the variable, so all of these are variables. Now, sometimes you would have a variable that does not have a number next to it. Sometimes you'll have a variable that does have a number next to it. The number is referred to as the coefficient. And this, together with the coefficient, is called a term. So in algebra, we may have an expression, which is everything on the left side of the equation. And it's it's a combination of terms that are combined with these operations. Now, in this case, I'm using the operations addition, even though it's the same as saying this is plus 4y and this is plus z squared. But it is also how we differentiate terms. So when we say how many terms are in an equation, we're talking about, in this particular situation, 1, 2, 3 terms, well, at least in this expression. So when we are simplifying an expression, we usually might reduce the number of terms by combining like terms. And like terms simply means terms that have the same variable that, and therefore we could combine. Because you can add the coefficients like you could add normal numbers, but you cannot really add x and y because they are variables and we don't know their values. Good. As we look more at the bigger picture, this entire thing from here all the way up to the equal sign is referred to as an expression. And I've said this several times: simplify the expression, factorize the expression, expand the expression. What makes the difference between an expression and an equation is the equal sign. Without an equal sign, these are expressions. So when I gave you a list of homework questions, let me pull one back up. This doesn't have an equal sign. It's a list of terms combined with operations. This is an expression. Now you can put an equal sign and simplify it and say, well, this expression is equal to this simpler form of the expression. But as in algebra, this is what we would refer to as simply an expression. What makes it an equation is when it has an equal sign. And what that means is that the value of everything combined on the left side is the same value as what is on the right side. So there is what I refer to as the anatomy of algebra. And I'm actually going to drop this in the chat for you guys to keep as a reference.
I don't write down that.
Well, that's all well and good, but I'll still have it there in its graphical glory for all to see. So I dropped it in the WhatsApp. Okay. The reason why I'm going through all of this is because the point is the terms. It may become confusing, and I didn't even go into exponents and base. We'll get into that in a future. But actually, it's kind of important because to talk about the exponent and the base, you do have situations where a variable is raised to the power of something else. And all that simply means is just like when you square anything, z squared is simply z multiplied by itself. Not 2 times z, not z plus z, z multiplied by z. So that is so, and this is no different from the operation of squaring anything. And you could also have z cubed, which would be multiplied by another z, and so on and so forth. The terms here that is important is the small number is usually referred to as the exponent. Sometimes it can also be referred to as the power, and the number that is being raised to is referred to as the base. And this is going to come in handy when we start talking about laws of indices and that kind of exponents and stuff like that. All right. What I really want to get into now is a new skill when it comes to algebra. So for the rest of the session, we're going to jump into um, expanding and factorizing. So one of this shouldn't be too difficult to understand. Expanding simply means if you have an expression that you multiply both by the same term, or by the same number, like a same coefficient. Let me give you an example. If we were to expand 4 times x minus 7, right? Now, this is a situation where, just like, no, in BODMAS and normal operations, you would work out what's in the brackets first and then multiply or do whatever is outside of brackets. Yes, Zane, go ahead.
So,
Yeah.
ah, so that like, and I the same thing like, how to say that way? Like 4 multiplied by x to get
It is,
4x.
it is the same as, not necessarily. It's not. This is not going to give you 4x minus 7, if that's what you're thinking. What you need
No,
to.
no, 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 no. And then after, gotta
Mm-hmm.
multiply 4 by 7
Mm-hmm.
to be 4x subtract 7 or some kind of thing. So, I mean, 4x multiply 4x subtract 4 by 7, which is, let's know, 28. Mm-hmm.
That's exactly what you would have to do. So the 4 is actually being multiplied by everything inside of the bracket. So the 4 has to be multiplied by the x, and the 4 would be multiplied by the 7. So that would give you 4x. 4 times x is 4x. And 4 times minus 7 would give you minus 28. Simple enough, right? Let me give you another one. If we have 3 times, say, 5x plus 4, what would we do here? Let me try Azriel now, since Zane volunteered to try this first one.
Um. Alright. So
What we are doing is simply the outside number is being multiplied by everything inside of the brackets. That's really what I just did in this one. So 4 is being multiplied by x minus 7. Since you cannot combine x minus 7, we have to multiply them separately. So you get
oh
4x
oh
minus 28.
yeah, I remember seeing a question like this before in a test I did.
Mm-hmm.
Okay, so 3 by 5x
Mm-hmm.
would be 15x,
15x.
and 3 by 4 would be 12. But you're supposed to put the same sign you see in the
That's
brackets,
right.
right?
You're supposed to put the same sign. Correct. Lovely. Let's try another one. So now we stepping up the game a little bit. The concept is the same. The operations and method is the same. I just changed up and added a few more variables. So
Okay.
Kanye, well, let me see if Kanye, I know we
So you
if
will get
Kanye could.
you end up with 6x plus 2xy.
There you go. You make it sound so simple. That is exactly what you would do. Now, the idea is again, we taken this as a term, as a factor. Now, one of the things I wanted to talk about is when you look at, for example, 6x or 2xy or any one of these things, there is a form of factorization where, because the variables are being multiplied together, so you don't have a multiplication sign between them, but we do know that 2xy it really represents 2 times x times y. The multiplication is there implicitly. And to save space, not just that, but if you have to write all of this, or yes, a lot of people write their x's like a multiplication and then don't know how to. Hold on. One second. Hey, Keisha. Right. What I was saying
Hi,
is,
sir.
aye, aye. Right. What I'm saying is that we have now when we, if you guys remember from primary school where you would have to do highest common factors, and there would be situation where you would break up a number. Let's say, the good old back in the good old days, we'd ask you to find the HCF of say 16 and 24. Now, the method you would use is you have a division, kind of like a line. See if I can draw it. These are lines to be light. Right. So you have a line. That's not what I wanted. Ah. And then you would put the numbers. Ah, I don't know. And you'd put 24 and 16. I don't want to do all of that, but and then draw a line, and then you would divide by 2, and then you divide by 2, and then you divide by 2, and then you divide by 3. No, no, no. Actually, is that how we would do highest common factor? No, no, no. What that is LCM. Highest common factor is where you would list out all of the factors of each one of these. So you'd break 16 into 2 by 2 by 2 by 2, and break 24 into 2 by 2 by 2 by 3. And then you will get the common factors being 2 by 2 by 2 and 2 by 2 by 2. You guys remember how that works? So 16 would be 2 by 2 by 2 by 2, and 24 would be 2 times 2 times 3. So the common factor would be this. Oh, that's terrible. Let me take off this. And this. Right? So these are the common factors. So the highest common factor, which means the factor 8 is a factor of 16 and 8 is a factor of 24. There are other factors that are common, but the highest common factor would be 8. So similarly, this is the concept of the idea of expanding and factorization. You have to remember that every term can be expanded out into individual factors. Like 15 is 3 times 5 times x. Let me give you guys one more of these. Sorry. Let's say we have 3x times 4x minus 5 y. How would we tackle this one? Zane, you want to give it a shot?
Um, just now, sir. Right. Right, sir. So it will be
Mm-hmm.
12x squared
12x squared.
subtract
Mm-hmm.
50xy.
That's right. Very good. So, you guys have the idea. Any questions? Ishaya, have you been? I know you kind of came in, but you understand what we are doing here. In these exercises, which are expanded, what we are doing is we have a bracketed group of expressions. Let me give you another one. Oh, let me finish explaining. And then we are removing the brackets by multiplying the outside term or the outside values by every item inside of the brackets. So I'm gonna give out another example. Let's say we have 5 times 2x minus 3y plus 6. So in this case, we have 3 terms in the brackets, but the concept is again the same. None of these can be simplified, and we are expanding, so we are removing the brackets by multiplying 5 by each item. So we multiply 5 by 2x, that will give us 10. We multiply 5 by minus 3y, that will give us minus 15y. And we multiply 5 by 6, that will give us plus 13. Does that make sense, Ishaya? Don't know if you hear me. Any questions? Everybody understanding what we're doing, right?
Yes, sir.
Yes, sir.
All right, good. So let me give you, okay, great. Let me give you guys some exercises to practice. Okay, so these are the 4 that I want you guys to work on as practice. And again, this is where you guys could feel free to, if you don't get it, that is what I'm here for, but give it a shot.
Me, sir.
Okay. I'll put a few extra ones, but I want to see, can work on it. Right, so this
Say I
last one,
finish.
say that again.
I say I finish.
All right, great. So try these last two, and should give you guys should be getting better and faster at these because it's the same process. This one just take your time because it might be a little tricky.
Sayonen.
Let the other students work now. Stop being a distraction.
Finish.
All right, so let's jump into these. These the first ones were fairly easy because these kind of like to warm you guys up. So 3 times a plus 2b, that give me 3a. We multiply 3 by a, and 3 by 2b would give me plus 6b. Then we have 7 times x squared minus 9. So this will give me 7 times x squared is 7x squared, and 7 times minus 9 is minus 63. Fair enough. 5a all multiplied by 2a minus 3b plus 5. So 5a needs to be multiplied by everything. 5a by 2a is 10 squared minus. I should let one of you guys tell me the answer for this one or no? Minus 15ab plus 5 by 5 is 25b. No brackets, that's the answer. Everybody got something like this?
Yes, sir.
Yeah.
Yes, sir.
So, Asriel, what do you got for this one?
I got 2x squared minus 8x squared plus 20x.
Close.
Close.
But
Wait.
if you got 2x squared minus 8x squared, could you combine those like terms?
Oh yeah.
Right. But don't, because that wouldn't be correct. 2x multiplied by 2x squared would give you what? What is
2x
x times
x
x
squared.
squared?
To anybody?
No, Zane. Calm down. We have, remember, x squared is x times x. If I multiply x squared by another x, that is x times x, which is the x squared, and then we multiply that by another x. And this
Oh,
is what, so what would that give us?
x cubed.
X to the power of 3, correct. So this is supposed to be 2x cubed, x times x squared. And I know I didn't give you guys that before, and it kind of could have been a curveball, but throwing that in as I'm going to introduce you guys again to more of the laws of indices and stuff like that. Minus, the rest of it was correct, minus 8x squared plus 20x. All right. Kisaya, you tried this one?
Which
M,
one, sir?
this one that I'm on here, M, the highlighted, multiplied by N plus 3M minus 5P.
No, sir, I missed that question. Sorry, I missed that question.
All right.
How I missed that question?
Well, Kanye, give me this one.
For I get mn plus 3m squared minus 5pm.
Yep. I mean, it could be MP, PM. Generally,
Mm-hmm.
will be in the order. Um, so yes, plus 3m squared minus 5. I'll put 5MP. All right, and for the last one, Zane, you want to tackle this one?
Yes, sir, no problem.
All right. So
So I get 12
mhm,
A squared B take
mhm.
away 10 AB squared plus 8 A squared B squared.
And
AB squared
AB squared, right?
and plus 8 A squared B squared.
Yep. That's the idea. That is the idea. So this is the concept of expanded. Now, expanding is actually the easier of the two. Now, I did talk about this topic being expanding and factorizing. So I'll spend the first half an hour explaining expanded. Now we want to talk about the second part of it, which is factorizing, which is basically getting from this back to this. So for example, let me go back to the first example that I did. I could remove this. So remember we had 4 times x minus 7 would give us 4x minus 28. Factorizing is starting off with 4x minus 28 and trying to find a common factor. Now, it is in a way you could think of it similar to, say, reducing fractions, where you have to find what is the largest factor that both terms can be divided by. Just like if you were to reduce 4 over 28, you would, you could, the 4s would cancel out or something like that. That would be where you're looking for a common factor. So in this situation, 4 is a factor of 4x because this is being multiplied. And 4 is a factor of 28 because 28 is a multiple of 4. So we can factorize both 4x and 28 with 4. And so how I would factorize is I basically would say 4x divided by 4, or how many times can 4 go into 4x, or there's certain ways you could think about it, but the idea is basically you are dividing 4x by 4, and I would leave you with x. And you are dividing minus 28 by 4, and I would give you minus 7. Again, the signs are going to be important. similarly with these, if I'm gonna do something similar to this, but not this exact one. But let's say we had 6x minus 8xy. So among the coefficients, the common factor would be what? What is a factor that could divide into both 8 and 6? Or what is a common factor of both 8 and 6?
2.
2. Both of them are even numbers. And this is where, of course, your knowledge of factors will come in. How to identify when a number is a factor of 4, a factor of 5, or a factor of 10, or a factor of 3. So both of these are 2 is a common factor. So we can factorize by 2. But we also have a variable that is a common factor, which is x. X is a factor of this term, and x is a factor of this term. So both 2 and x are common factors. Therefore, this would be factorized using 2x. So if I divide 6x divided by 2x, that would give me 3. And if I divide minus 8xy divided by 2x, the 2 would go, 8 would go into, the 2 would go into 8 and give me minus 4. And the x would cancel out this x, so I get minus 4y. Now, whenever you're doing factorizing, this is one of those opportunities where you can double check your number. If you factorize and you work out and get something, you could always take this and expand it to see if it gives you back what you originally started off with. And if it doesn't, then obviously you did something wrong. So let me give you another example. But any questions so far? It's basically the reverse of what we were doing with expanding, where the result is a common factor, and then the terms that cannot be grouped are inside of the brackets, and it cannot be simplified any further. Let's say we have 3x squared plus 15x minus 12. What would be the common factor here? Ishaya, I'm gonna pick on you since you were kind of quiet, if you're still here. All right, well, I don't know where Kishaya went. Azriela, what is the common factor in this expression before the equal sign?
Um, 3.
3. It would not be 3x because even though 3x will be a common factor for these two, we have to look at everything. So I included all 3 terms, and the only common factor is 3. So this would be simply 3 times. And then we are dividing, how many times? Dividing 3x divided by 3x squared divided by 3 would give me x squared. 15x divided by 3 would give me plus 5x. And minus 12 divided by 3 would give me minus 4 in brackets. And that's the idea. All right. So without any questions?
So this is just the reverse of what we were doing.
Exactly, exactly. So we would usually start off with the expanding explanation, but it go hand in hand. This is, and I use the first one exactly as an example to show that if we start off with 4x squared, 4x minus 28, factorizing it will give us the 4x 4 times x minus 7, which is this. So it goes, so it's, yeah, it is the reverse. You're starting from this side and going in this direction where you have a factor and the brackets with the other terms. So we start off with the expanded version and we go into the factorized version. Right, so let me
Okay.
give you, good. So let me give you guys some to practice on. Any questions, anything?
All good.
All good. So right, so these, take a shot at these. These are factorize the following. Following. Let me give you guys one more for the ones that finished. A bonus. So I made this one a little extra spicy, but I hope you guys could follow it. All right, so let's wrap these up. Of course, the first few were pretty simple. So the common factor here would be actually, you know what? I'll write it. Common factor here would be 5. So this would be 5a minus 2b. The common factor here would be 6. I don't know, actually there was one I should have given you guys. So 6 is the common factor in both 6x and 12y. So this would be x plus 2y. Here we have the only common factor here would be x. So this would be factorized as x, 3x minus 4. This one, let me call on Kanye.
12xy plus 8y squared, I get 4y, open brackets, 3x plus 2y, close brackets.
Yep. Well, y is the correct. 3x plus 2y. Very good. What about this one, Azrael?
No, every time I say don't call me, you're calling her. Um, the
What you
common,
got for the common factor here?
I got 2.
Okay.
So it's 2 open brackets, 7 x squared
Mhm.
plus 8y squared minus 5z squared.
That's right. No, I did this one because I wanted you guys to understand that the squared is not a factor. That has nothing to do with the factor. X squared is a term. Just because all of them has 2 as the power doesn't mean you could use something like factorize the 2 or put the 2 outside or anything like that. It doesn't work like that. All right. And for this one, I guess I don't know. Zane, you still here?
Yes, sir.
All right. So what do you got for this one? What is the common
The time
factor?
3AB.
3ab.
Yeah.
All right. So if you have,
So which one you would use, right? 3AB or 3AB squared?
well, what is the highest common factor that is common among all of them?
3AB squared.
3ab squared.
All right.
Now, here's the thing. Yes, 3 is a factor of all of them. A is a factor of all of them. AB is a factor of all of them. But what we want to do when we factorize in is what is the highest common factor. So it's not that you, if you were to just put 3AB, you would still have inside of the bracket a common factor, which would have been another B. So the biggest common factor is 3AB squared.
All right, sir.
But yeah.
So 3AB squared, open bracket, 3 plus AB, take away 2A.
Everybody understand how we got this?
No, sir.
All right. What it is you use as the common factor?
3ab.
3ab. So you would have gotten 3b plus what? What would you have gotten inside of the brackets?
Oh, well, I saw it as this, since I'm using 3ab,
Mm-hmm.
that means, oh, but
What would
then
be
this doesn't
inside here?
make sense.
Hmm?
What I want to, because I now seen it here that this doesn't make sense. I want to get 6a squared and b cubed, so that, and b squared, so that doesn't make sense.
What do you mean? How did I get
I
6?
got, so my answer was 3ab,
Right.
open brackets, 3ab plus ab minus 2ab, but I'm watching it now, that doesn't make sense.
Oh,
Yeah, I was thinking it from a different point of view, and I kind of got confused with the in the beginning.
yeah, I know. This is, like I said, this one I did make. And in all reality, you probably won't have something this. I remember seeing something this complicated in an actual exam, but I want you guys to be able to do up to this level, obviously. So this is how you would factorize this particular type of question.
All right, sir.
Right. Anybody else? Anything else that I need to explain? Anybody do understand anything? How I got how I got this last one or any of these? I need me to go it over.
No, sir.
All right. Everybody good? You speaking for the whole class or just for you?
I good as well, sir.
All right. Nice. All right. Good. So again, this is step that is building one on top of the next, and is again this one, these I would say series, especially algebra, is this part of it is kind of fundamental, and it might be easy if you guys are already familiar with it, but it is also very important because everything else that we do builds upon it. So don't sleep on these classes, and then something about it that you might have learned how to do it the wrong way, or you don't do it this way, or maybe I might talk about something that you haven't seen before. I want you guys to pay attention to this because everything else is gonna be based on the fundamental knowledge of classes that we starting right now. Right? So with that said, we can wrap up and I will post some homework questions for you guys tomorrow that would be in this similar vein. These are actually pretty simple, and I'll keep it simple for now, but we will gradually make it more complicated because there's a lot of complexity ahead. So get the grip on the simple ones like what we're doing right now. Right?
Yes, sir. Are
Yes.
you in the homework? Are you bringing the one with the previously that I get wrong in the homework?
Which one was that?